let's see case number 3. If you substitute the value of a inside your function f, you'll get something with constant over 0. So if you found something like this, we need to find the limit from the left hand side and also from the right hand side. And the answer might be either infinity, negative infinity, or does not exist. So let's try to look at the examples of case number 3. So these are the examples. Let's see the first one, limit of 1 over x minus 2 squared as x approaches 2. So if we put in 2 inside the variable x, we will get 1 over 0. So this is the case of the third one, constant over 0. So now what you should do is you need to find a limit from left hand side and also from the right hand side. And after that, we need to conclude our answer. So let's try limits from the left first. Limit of this function 1 over x minus 2 squared as x approaches 2 from the left. So let's take one value 2 from the left. You can take the value of 1.9. So let's fill in 1.9 inside here. Actually, we know the answer will be either infinity or negative infinity because 1 over 0 will result to positive infinity or negative infinity. However, we are not sure about the sign, whether it's positive or negative. That's why we need to find a limit from the left hand side and also the right hand side. Let me show you how to do this. Let's start with the left hand side, limit of 1 over x minus 2 squared as x approaches 2 from the left. So what you should do is take one value 2 from the left. So the closest one is 1.9. So let's fill in 1.9 here and let's check the signage whether it's positive or negative. So numerator is 1, 1 is a positive. And for your denominator, 1.9 minus 2 is a negative number, negative squared is a positive number. So positive over positive, it will result in positive. So the answer is positive infinity. Next, let's see 2 from the right, limit of 1 over x minus 2 squared as x approaches 2 from the right. So let's take one value, 2 from the right is 2.1. So let's try out the value. Numerator is 1, so this is positive. And when you put in here 2.1, 2.1 minus 2 is positive, positive squared is again positive. So positive over positive, this is positive infinity. Therefore, let's conclude our answer since limit 2 from the left is infinity and limit of x approaches 2 from the right is also infinity. Therefore, we can conclude that the limit of 1 over x minus 2 squared as x approaches 2 is equal to positive infinity. Next, let's see question number 2. Limit of x squared plus 1 over x minus 1 as x approaches 1. So let's try to substitute the value of x as 1. So if you put this as 1, your numerator is 2. And if you put 1 here in your denominator, this is equal to 0. So obviously, this is case number 3, which is this is constant over 0. We know that our answer could be positive infinity, negative infinity, or does not exist. Therefore, we need to check our one-sided limit. So let's check one by one. So let's start with 1 from the left. So limit of this function as x approaches 1 from the left, take one value, 1 from the left, so let's take 0.9. So let's check for your numerator. If x is 0.9, this is a positive value. And for your denominator, if your x is 0.9, this will give you a negative value. So positive over negative, it is a negative. Therefore, the answer here is negative infinity. Now let's check for limit as x approaches 1 from the right. So let's take one value from the right. Let's say 1.1. So let's check 1.1 squared plus 1. This will give you positive. And for your denominator, 1.1 minus 1, this will also give you a positive value. So positive over positive, you will get a positive value. So the answer here is positive infinity. So let us conclude our answer. Limit of x approaching 1 from the left is negative infinity. Limit of x approaches 1 from the right is positive infinity. So since the value are not the same, we can conclude that limit of this function as x approaches 1 does not exist, since limit 1 from the left is not equal to limit of 1 from the right. Now let's proceed with question number 3. This is the function, so let's check. Let's put in a value of x equal to 0. So your numerator is 1. And for your denominator, 0 times any value here, this will give you 0. So this is the case, obviously, where you have constant over 0. Let's check the limits of left and right to decide what is the answer. So let's check The first one, limits of this function as x approaches 0 from the left. So let's take one value. 0 from the left is negative 0.1. Let's put it in our numerator. So this will give you a positive value. Now let's put it in our denominator. So the first value here will give you a positive, and this value here will give you a negative. So the resulting sign from here is negative. So the answer is negative infinity. Now let's check 0 from the right. Let's take one value, for example 0.1. So let's check for your numerator. If x is 0.1, this will give you a positive. If this is 0.1, 0.1 squared is a positive. And if this is 0.1, therefore it will give you a negative. So the resulting sign will be a negative. So your answer is negative infinity. Therefore, let's conclude our answer. Since limit of x approaching 0 from the left is equal to limit of x approaching 0 from the right, which is negative infinity, therefore we can conclude that the limit of this function as x approaches 0 is negative infinity.